So in this video, we're going to talk about area between two curves. So we have two curves, F and G here. So I'm looking to find this area between those two curves, cut it from A to B, okay? So in general, to find the area between two curves, I need to think about the area of a rectangle. So forming an arbitrary rectangle here. Area of a rectangle excuse me, is the height times the base, okay? So I need to figure out how to calculate the height of the rectangle. So this distance here, from here to here, well, the top function, f of x, minus the bottom function, g of x. So it's the top minus the bottom, so the high value minus the low value gets you this distance right here. Okay, so that's the height. H is the height. So that's that first part here. Now, the width, there's a change in x here. We're changing from x to x to x, right? So we're changing here. So this is changing along the x-axis. A delta x here is the base, the width of this rectangle, delta x. The height is f of x minus g of x, the area between two curves, okay? The area between curves. That's what we're talking about here. So that's the area. So area for a rectangle, to find the area of that rectangle, f of x minus g of x. In general, with our theorem, for two continuous functions, so say we have two functions like f and g, those are continuous on some interval. Now, I want to make one of those functions, since they're both arbitrary, I want to make one of them bigger than the other one. And so I have f of x greater than or equal to g of x, okay, on this interval. So it's always bigger than it for every x value in this interval. So this is a set notation. This is more of an advanced calculus notation here. So what this reads is for all, that symbol here is for all x, and then this symbol here is in the interval from a to b, x equal a to x equal b. So what this says right here is for every x in the interval from a to b, we have f of x greater than or equal to g of x. So it's just a fancy way to say that your f function is always going to be bigger than your g function on a to b. Okay? So don't get too discouraged by that there. The area of the region bounded by the curves, y equals f of x, so that's that top function, and y equals g of x, that's that bottom function, and the lines x equal a and x equal to b is found by the definite integral defined to be from a to b, okay? So we start. So here's the idea. Okay, well, let me actually finish the formula, then I'll talk about the idea. The integral from a to b of f of x minus g of x, okay? So remember, in integration, this elongated s, you remember what that stands for? That's the sum, right? So it's a sophisticated way to say, hey, I want you to go add all the areas of the rectangle. So how do I know it's area of a rectangle? Well, this is the height times the base, right? So base times height here. So how do I know it's the base times height? Well, what do I know? F minus G, top minus bottom, is how tall the rectangle is. Delta X, that's how wide the rectangle is. So I'm literally saying for some arbitrary x value, here's the height and here's the base. Now I'm taking all those base times height, and I'm summing up all the infinitely many rectangles between A and B. So what does that look like? So I take this arbitrary rectangle here, okay? And I'm literally summing it up, starting at A, and I sum it up, boom, 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 all these infinitely many rectangles that I've got going on here, all the way to B. Okay, so just infinitely many rectangles, as many rectangles as you could ever believe in, and then add in 35 more, right? And if we push that number of rectangles to an infinite amount of rectangles, what's happening to that delta x width? That delta x width is limiting to 0, right? The more rectangles you put in there, the smaller those rectangle widths have to be, right? So you think about it, we just filled up that whole picture, but inside the picture, we could like zoom in like way closer, right? And we could have like, holy cow, we could make this even smaller, right? I could put all these little bitty rectangles even inside there. And we could just play this game over and over, zoom in even closer, and you just have as many rectangles as you could ever believe put in there. Okay? All right, got a lot of rectangles to erase out there. Okay. So hopefully that makes a little bit more sense why it's defined the way that it is. So that's the height. And then we have the base, and that's the base. So the area of a rectangle. So in general, you could think of it like this, okay? So what this is saying is add all rectangles areas from A to B, okay? And where the areas of the rectangle are the height times the base. Okay, so in this example, I want to sketch the given functions and then find the area of the enclosed area. So maybe I'll make this a new video since this is already